Now in this lecture we are going to look at another type of open addressing technique, which is double hashing. Now in case of double hashing, we are going to use two hash function. So here interval between probes is computed by another hash function over here. So let's look at this example over here to make things very clear. Now in this case we have called hash function for these strings over here, and we have got for all of them 2. And we are going to use the second hash function and call second hash function for these strings over here. Now the first string is ABCD. Now when we are calling hash function for ABCD, we are getting index of 2. Now in this case, if we check the index of 2 in this hash table over here, we see that at index 2 we don't have any element, so we can insert this ABCD to this hash table over here. Now after inserting this, we are going to continue to the next string. So in the next string we have EFGH. So if we call first hash function for this string over here, we are getting index of 2. So we are going to check index of 2 in this hash table over here. We see that at the index of 2 we have another string over here, so this means that we cannot insert it at the index of 2. So that's why we are going to call second hash function for this EFGH. So in this case, second hash function returns 4. So this means that if we sum up these two results from hash function 1 and from hash function 2, we are going to get the index for the second string over here. Now if we sum up them, we are getting 6, so this means that we can insert it at the index of 6 over here. Now after inserting this, we are going to call first hash function for this third string over here. Now after calling it, we see that it's returning 2. So we know that at the index of 2 we have another string, so this means that we need to call for this string over here second hash function. So if I call second hash function, in this case it's returning 4. So if we sum up these two results from both hash functions over here, we are getting 6. Now if we check the index of 6, so we see that at the index of 6 we have another string over here. So this means that we cannot insert third string at the index of 6. So in this case, what we are going to do, we are going to take the first index and we are going to multiply the second index that comes from second hash function with the 2. So in this case, the calculation will be like this. So we will get index of 8 over here. So this means that we can insert this string at the index of 8. Now after doing so, if we call these two hash functions for another string over here, and we get that from the first hash function we have 2 and in the second hash function we have 4. So if we do the same calculations, we will see that all these indexes over here are occupied. So in this case, we are going to continue to multiply the second index that comes from the second hash function with the 3. Then we will check that index. So if it is occupied, we are going to continue to multiply it with 4 or 5, and it will continue like this until we find the empty cell in this hash table over here. Now with this, we have explained the logic behind the double hashing. Now based on this logic, let's head over to Java and create double hashing in practice. Now here, we are going to implement double hashing in this double hashing file over here. So basically what we have done over here is we have imported array list, then we have created double hashing like this. So basically these parts of double hashing is same as with the linear probing and quadratic probing. That's why I have just copied the codes from the previous lectures and passed it over here. So first we are creating hash table with the type of string array, then we are creating another variable in which we will have the number of cells used in hash table. Then inside constructor, we have initialized the hash table by using the size that comes from the user, and we have set the number of cells used in hash table to 0. Then we have created first hash function like this. So this is the hash function that we have created before. So that's why I'm not going to go to the details of this hash function over here. So in this case, we are just taking the ASCII values of the characters and summing up them. And based on the length of the hash table, we are getting the mode of this sum over here. Now then, the next method is rehash keys. So this method also is created in the previous lecture. So basically what we are doing over here is we are just creating array list and transferring all data from hash table to this array list. Then we are inserting new string to this array list. Then at the end we are creating a new hash table with the size of 2x, and we are inserting all elements to this hash table over here. Now finally, then the last method that we have implemented over here, before is display hash table. So by using display hash table, we can display all elements of hash table in the console. So this makes our life easier when we are visualizing the hash table. Now here, after these methods, we are going to implement second hash function, and we are going to implement insert in hash table in case of double hashing. Now for creating second hash function, I'm just going to create another helper method over here which adds all digits together. So it's going to be private int, and the name of method will be add all digits together. So this method will take as a parameter sum, and here inside this method, the first thing that we are going to do, we are going to create a value and we will set it to 0. Then we are going to loop while sum is greater than 0. In this case, we are going to set the sum mod 10 to the value, and sum will be equal to sum divided by 10. Now with this, we are adding the digits all together. At the end, we are going to return value over here. Now we are going to use this function inside second hash function. So after this function, I am going to declare our second hash function like this. So it's going to be public int. So the name of function will be second hash function, because in case of double hashing, we need two hash functions. So this is the second function that we are creating over here. So as a parameter, it's going to take string. So I'm going to put it x, and the second parameter will be integer. It's going to be length of hash table. So in this case, I'm just putting m over here. Now what we are going to do over here, first we are creating char type of array over here. So it's going to be ch array. Then I'm going to set ASCII values of the characters to this ch over here. So it's going to be like this, x dot to char array. Then I'm going to create two variables over here for loop. So it's going to be I and sum. So then we are going to loop through this string over here until we have visited all characters of this string, and we are going to sum up their ASCII values. So the loop will be like this, sum is equal to 0 and I equal to 0, and it will continue until I x dot length. Now inside this loop, we are going to sum the ASCII values of characters. So it's going to be chi. Now after doing so, we are going to write loop like this. So while sum is greater than hash table dot length, in this case we are going to set the value that comes from this function to the sum. So in this case, it's going to be like sum is equal to add all digits together with the parameter of sum, and at the end we are going to return sum mod m. Now with this, we have successfully implemented our second hash function. Now after implementing second hash function, we are going to create insert key in hash table method. So in this lecture, the main method that we are creating over here is insert key in hash table. So before creating insert key in hash table, I'm going to create another helper function over here, which will be the get load factor, because based on the load factor, we are creating a new hash table with the size of 2x. That's why here we need to create get load factor function over here. So it's going to be calculated based on the number of cells used in hash table, multiply with 1.0 divided by hash table dot length. Now with this, we have successfully implemented our get load factor method. Now after that, we are going to implement public void insert key in hash table. Now this method will take one parameter, so it's going to be string value. So this is the value that we want to insert in our hash table. Now here, the first thing that we are going to do, we are going to create load factor, and this load factor will save the value that comes from this get load factor. So based on that, we are going to decide that if we want to create a new hash table or not. So load factor is equal to, so let me just copy this load factor from here and pass it over here. Then based on that, we are going to call rehash keys method, or we are going to insert this new value to the hash table over here. Now here, if load factor is greater than 0.75, it means that we are going to call rehash keys method with this value that we are getting from this parameter over here. So if condition will be like this, if load factor is greater or equal to 0.75, in this case, we are going to call rehash keys with this value. Otherwise, we are going to look for empty cell in this hash table over here. Now, the first thing that we are going to do, we are going to get the first index from the first hash table. So it's going to be like this, int x is equal to, so we are going to call first hash table. So the first hash table is this one, simple ASCII hash table. So we are going to call it for this string over here, for the value that we are getting from the parameter, and the second parameter will be hash table dot length. Then we are going to call second hash function for this value over here. So in this case, it's going to be integer y is equal to second hash function for this value, and the second parameter will be the hash table dot length. Now, after getting these indexes from both hash functions over here, we are going to loop through the hash table and look for the empty space in the hash table. So it's going to be like this. For I starting from 0 and continues until the length of hash table, and in each iteration is going to be increased by 1. Now, based on these two indexes, we are going to calculate the new index for inserting this value to the hash table. So it's going to be calculated based on the equation that we discussed. So it's going to be x plus I multiply with the second index, and it's going to be mod hash table dot length. After doing so, we are going to check that if at this new index in the hash table we don't have any value, we are going to insert that value to this new index over here. Otherwise, we are going to continue looping until we find the empty cell over here. So it's going to be like this. If hash table with new index is equal to null, in this case it means that it's empty, so we can insert this new value to this hash table at new index. So it's going to be like this value, and then we can print out to the console saying that this is inserted at this index over here. So it's going to be like this. System out println, so we can put value plus inserted at location new index. Now, after doing so, we are going to put break over here because we have to stop over here. Otherwise, we are going to continue to look for the empty cell. So in this case, in the else condition, I'm going to put like that. New index is occupied. Try next empty index. Now, after doing so, at the end, we are going to increase number of used cells in the hash table, because here in this case we are inserting new element to the hash table. So after this if condition over here at the end, we are going to increase this variable by 1. Now with this, we have successfully implemented insert key in hash table in case of double hashing. Now let's see how this is working in practice. Now here inside main class, we have created an instance of double hashing, and one more time, I'm going to insert the words that we have inserted before in case of linear probing and quadratic probing. So these are the words that we have inserted before. So I'm just going to insert in case of double hashing them over here. Now after insertion, we are going to display hash table to see the results in the console. Now if I run our code, you see that in this case, it's inserted all words over here to this hash table successfully. So for some of them, it causes collision, so if there is a collision, it's continuing to look for the next empty cell in this case. Now after inserting, we can see our hash table in the console like this. So here you can easily see that all elements are inserted to the hash table successfully. Now with this, we have come to the end of this lecture. So in this lecture, we have implemented hashing in case of double hashing. So here we have not implemented search and delete method in case of double hashing, because search and delete method in case of double hashing is same as in case of linear probing and quadratic probing. So that's why you can just copy the code from there and pass it over here. So with this, we have come to the end of this lecture. So hopefully everything is clear about double hashing implementation. So see you in the next lecture.